analysis for this building, because we have not done the structural analysis and all that. As I said yesterday, that for me, I like to model everything, both the foundation, before I now begin my structural analysis. That is, if I am doing a slab raft and all that. Look yourself. Who is that? Okay, that's fine. Sorry. Okay, so right now we'll now begin with the structural analysis. That's coming in. So what I'll do now is to go to the analysis tab. On this tab now, you see building analysis here has not been done and all that. So on that now, so on this node now, I'll click on this building analysis here. On clicking on that now, there's some settings we have to make, which is the materials and all that. Okay. Okay, so on this now, I'll just come here and then choose edit materials. And from edit materials here, I'll just choose my concrete grade, which I'll use grade 25. So for you to be sure of the grade you're using, once you click on this grade value here, make sure you put your eyes here to see the actual grade. So we're using grade 25, and then I'll then come here and then click here. Okay, so on this now, I'll then say okay. Then I'll come to my steel grade. On the steel grade now, just click on any of them, and I must make sure I choose this select all. Now we have several steel grades here and all that. So you can choose 410 or 460 or 500, depending on the country you are dealing with. Now, if you look at each of the grades has their own bar notation. Grade 10 will give you Y notation. That means you're having like Y16, Y10 and all that. If you want to have a T, which is the highest steel, you have to use grade 460. Grade 460 will give you T, as you can see it here. It gives rebar symbol to the T. So you're having T60 and all that. For other countries like US and Canada, they use this H. They use this H in US. Canada uses M in their own bar notation. So for 500, you have to get it to give you H and all that. Although you can still change it, just like as it is for like other countries, Canada, they use M. So they have like M20, M15, MH, M14, and all that. So what they use is N. So you can still change that. But in this case, I would use 460 type 2, which is the rough type. So we change to this instead. Let's name that. Okay, so I will use 460. I will use 460 type 2, which is a rough rebar and not the smooth rebar. I'll now come now and then click on the rebar diameter. So I'll click on this place now. I want to choose my rebar diameters and all that. So to choose the rebar diameters, I'll just deal with the standards based on minimum number and minimum rebar size for column, for wall, since we have a lift wall here, and then for beams and for slabs. So with that now, I'll come here, this icon here, this is for column. I'll just come here and just choose, I want to start with 16, which is the minimum for column, 16, 20, 25, 32 is too big. I'll come for wall, we have a lift wall here, so same thing, 16 minimum, 16, 20, 25, 32 is too big. For beam, 16 also, 16 minimum, 32 is too big, 16 to 25. Then this is slab. For slab now, 12 is okay. So, but since we have a slab raft here, I'll still leave 16, 20, and 25. But for the superstructure, it will use only 12. Then we don't have roof slab here, so I'll just leave it as it is. Then for footing, foundation, I'll leave everything there. For the links, I like to use the 10 for my links and all that. Although most people can still use 8, but I like to use 10, so I'll just use only 10. Then for the sidebars, for the walls and everything, longitudinal bars, I will use let me allow. I will use 12 for the sidebars for the walls. Let me this. Okay, so I'll use 12. So I'll just uncheck 10, 12, 16, 20. I will check this with that too. For the other direction, I will do the same thing again. Uncheck 10, 12, 20, 25, and remove this. Then for this generic, I'll just pick 12. Okay, that's fine. So with this now, I've choose the bar diameters which I want for each of my members, column, beam, and all that. So I'll come now and then click on OK. So on OK now, I'll then come here and click on the final OK here, and then another OK here. So on this now, since this building has a wind load, although we have already applied wind load before when we are doing the modeling, but I'll just reapply that. I will come to setting center here, setting center, and then go to my codes and make sure the wind code is there. We are using what? And we are using Euro code, so it's already here. I'll just say okay and then okay. Now the reason why I'm adding wind load is what, because of the height of the building. This is 20. You can see it here, 20.4 meters and all that. And wind load starts from a building or any structure at the height of 10 meters. So this is already 20. So at this height, wind effect will be much on this structure. So I'll have to add wind load. Then I'll come to this place, load combination, and make sure that wind load is also part of the, you can see here. So I'll make sure I check this wind load here and also check this one too, notional loading. And I'll come here and say okay. And then okay it here once it's done. Let me allow someone to come in. Okay, that's fine. So on this now, I will then come to this wind and story loads and all that. Now, if you're using 2018, most of the version of 2018, you will not see this and all that. If you don't see this, that means that is the version that has that wind load issue. Because most of the 2018 version, you will not see this wind load and story load and all that. That means that you cannot add wind load. So I would advise you just go and install a new 2018 version if you're using 2018 up to now. Okay, so with this now, then come here and click on this place, wind and story load. Then I'll come and click wind load calculator and all that. Now, basically, I've told you guys before that when you are dealing with wind load, you have to know the wind speed at that particular region where the structure is to be sited and all that. For example, I will use a typical example of Lagos, Nigeria. Now, Lagos, Nigeria generally has a wind speed of 30, which is the same thing with wind speed for London, UK, and all that. So in that case, I will use 30 meters per second for the wind speed and all that, assuming this building is said to be in Lagos. So I'll choose that. But if you cannot get this, I would advise you go to Google or you make a research for the particular wind speed of that city you are working with and all that. So then I will leave this key heights and all that. We have basically done more videos about wind load and all that. So I'll leave everything here as default. Then I'll the same thing here. I'll come here. I'll choose it because since it's Lagos, that means that Lagos is already a developed place. So it falls under this category 4. We are at least 15% of the surface area is what all have buildings. So I'll come now and then say okay here. So on this now, if you want to create a report for the wind, you can just click here for the report, and then you get your wind report based on what you have imputed. Let me see. Okay. Okay, please let me know. Someone said my voice is breaking. Let me just understand that. Someone should confirm that.
I think you already do enough.
Okay.
I think it's okay.
That means maybe that means it's the person's network. I
This
believe
network.
so. Okay. Yeah, I think so. So with that, now just come here and say apply, and then I'll say okay here. And on doing that okay now, the next thing I'll do now, that means you have applied everything for that. I'll then come to analysis tab here. Now on this now, I'll just come directly here and then check this. Okay, look at it, do BD model check. Let me just check that BD model check and then start this. Okay, so you just check your model if you have any serious error or warning and all that. If there's any serious warning, just go and rectify that. So let's see if there is any serious warning here and all that. I'm already seeing one, but this is saying that this is about axis. The vertical axis is at the angle of this. I'll just ignore that. That's not an issue. Let's just finish running. So okay, this is 8 errors. So let's see where the error is coming from. This error says vertical axis 16, A16 is so and so. I'll just ignore that. It has an angle of this. I'll ignore that. The same thing, axis AM. I'll also ignore that. Then let me go up again. This is the same thing, axis 2. I will ignore that. That these two axes, they are what overlapping. I will just ignore that. It's that one now that says slab at story 6 has a very small area. Yeah, I can still ignore that. Story 6 is at the roof side. So, you know, when we are doing this building modeling, before, we are at this story 4, we applied a parapet slab at the roof, because this is the story 6. So it's saying that I think it should be this one, that it has a very small area and all that, because we don't want the parapet to be too big. So I'll just ignore this warning because they are all at 36, and all the one is saying that is very small, is very small, very small. I'll just ignore that because that is not actually a slab, that's a parapet and all that. So I'll just ignore that, and then I'll just come here and say, so that's the only warning that makes it up 8 warning. So that's not a serious warning. So I'll just come here and say close. So by doing that now, I will then basically, once I've done all that, before I begin my analysis and design, I normally close and then save. Because if anything happens during the analysis and thing when goes off, everything you have done, all those settings. So with this now, I will then come back now and click on building analysis here, and then just go straight to my analysis tab and then this other place here. So on this now, I will first of all run the building analysis first without my design. So I just run the building analysis first. Now, for me not clicking this column and this beam design, what it means is that I want to run only the building just the building analysis first. So I'll come here and run the analysis. Okay, so right now it is running. Let me let someone in. Okay, splendid. Okay, so let us go back there. So right now it's running the building analysis and all that. So while that is running, I wanted to open Quota 2022, because this is 2024 we are using currently. 2022. Let someone in. Okay, come in. Someone to come in. Let me see. Okay, so it's still running the building analysis. I'll then go back again. I want to open 2022. Structure 2022. 22. Let me see if I can get that on my document. Documents. Okay, apps. Let me see. Now this is window apps. Okay, because this Okay, this thing cannot minimize while you're running the analysis. Okay, but let's just hold on for that to open up. So why this is going on? If you have any questions so far, then you can just ask, and I know that you can ask why it's going on. Okay, and if this is the first time you're coming and you missed yesterday's training, don't worry. By the end of this week, that was on 26th, I will attach all the links to, because we are currently recording this training. So I'll send all the links so that anyone can be able to download that and all that, or watch that directly on the channel or any of that. Okay, so any question can come in while this is still running. Okay, so right now, just as the name implies, structural analysis. So this one I can just, this is 5.0. I'll just ignore that. Just say okay. Let me see, continue. Still continuing. Okay, why we are okay? Now you can see this. Now, when you're running your building analysis, this must be what satisfied. You must see good here and not here, and also here too. Most times you will see an X. Now, when you see an X, what it means is that is what story drift. It means that the weight coming on the structure or on the building is more than what the vertical members can carry and all that. That is if any of this is failing and all that. So what you do in that essence, if it is failing, if there was no good here, there's an X, is to increase the size of the vertical members. That is one. Or you add more vertical members and all that. So for example, direction 1 here might be failing and all that. So if direction 1 is failing, it means that you are meant to add more vertical members on the horizontal plane of the building.
Sorry, somebody said
and,
it's not in the screen, sir.
And if sorry, what do you say?
Somebody said it's not seeing your screen. Somebody said it's not seeing your screen.
I think that should, but are you seeing my screen?
Yes, I'm seeing your screen. I'm seeing your screen.
Yeah, I think that might be his either his or our network and all that. Yeah, but I don't know if anyone is having that issue too. Not seeing the screen. Can just verify that. Okay, so like I said, as I was saying, if you have any issue on the story drift, try to add more vertical members on your building or on your structure. That's it. But in this case, everything is fine. So I'll come down and say okay, and then let me see. Okay, that's fine. So I'll just let me see. Someone want to join. Let me just see. Someone raise hand up. I don't know. Fashion, your hand is raised up. Any question?
Not really a question, just to add to what
Okay,
you have said concerning the story drifts.
Okay, yeah. Okay, you can add that while I accept this to come in.
All right. In addition to that, at times when he's showing you that X, just like what you have rightly said, by the time you click on OK, you notice that some of those vertical members are failing. It will actually indicate that they are failing. So once it's failing, all you need to do, just as I said, is to go and do what and increase those parts that are failing. Though don't forget that you are still going to do what we call interactive design on those column on those members, whereby you are able to detect those errors and how to increase it. So, but once you are seeing that red, whatever direction 1, I think it means X axis, and direction 2 means Y axis. So by the time so when it's showing you that, just click on close. By the time you now check your design status, you now see those members that are failing, in which you are going to increase their section to be able to pass the design. I think that's what I want to answer.
Okay, that's fine. So right now we are done with the superstructure analysis and all that. You can see it here completed and all that. We can then close. Don't forget, what we have just done is just the structural analysis and not the design yet and all that. Now, knowing that our main focus is on the slab raft and all that, because I believe before this time, you must have known how to perform structural analysis and design of a superstructure and all that. And this is just a 5-story building. I'm doing this just to beat up the time, knowing that we have a maximum of 2 hours for this training. So right now I have done the structural analysis, which I have gotten all the reactions and everything down to the foundation. Now, what I will now do now is to move on to the substructure and all that. But if you want to perform the design for the superstructure, because we have just done the analysis now, which is showing okay. Now you can go to design tab here and then click on design all. Now, based on the how this building is a massive a bit, if I do design all, it might take us at least 20 minutes or something before the design will be able to finish up, and that's a really much time and all that. So going to our focus, which is the slab raft, that's where I'm going now. So I will still go back to what building analysis here. So in that course, I will skip the superstructural design and all that. So the reason why I did this analysis was to get all my reactions down to the slab raft and all that. So in this case now, I will then go back to story. I'll make story 0 active. So I'll go to story 0, click on story 0, active here. I can, story 0 active. Then on this story 0 now, I will then come again, come to plan view 2 and make story 0 active. Come to story 0 here and make it active. Okay, now I turned off those grid lines and all that analysis just to have a clearer view of our slab rafts. Okay, so this was what we did yesterday. Now, once you're done with your superstructural analysis, it now boils down to the substructural analysis. So we then, to not do that now, you have to go to FE analysis, FE foundation analysis. Note, we have two types of what analysis. We have building analysis and we have finite element floor analysis. Now, this is mostly used. We can still use this for a normal beam system for all that. But for me, I normally use this if I am working on flat slab. Yeah, flat slab. That's where I use this floor analysis and all that. Now, it is not an option. It is an option actually. You can choose to use that when you're doing a slab raft or a mud foundation to use this analysis and also this one too and all that. But I want to use only this building analysis results and then transfer it down to my foundation FE foundation analysis. Okay, so with that now, I'll just come here and click on this FE foundation analysis. Now, on this now, I will then come here and then use the short charge reaction. That's okay. I've already explained. Let me allow someone to come in. Yesterday, I've already explained about this short charge coefficient and all that. Where I explained that this is the average, which is the best for you to use. But if you want to change it, then you must have to know what they call upper limits and lower limits based on coefficient of what of such a reaction. And for you to study this very well, you have to go and read this book written by Joseph Boyce in 1995 and all that. So, but this is the average that was given by this man. So I'll just cancel and use the average, which is very nice to be used for any type of design based on such charge coefficient, except you have done your own test very well and you've gotten your own such charge coefficient. So in this case now, I also include, I'll click on this place to column section in the FE model. Okay, allow this to come in. Okay, so I will include this. Then this building is not that big actually. I think it's up to, let me see, 8-story, 10-story, or 9-story. I would have chosen to apply life load reduction. Although you can still choose to apply it, but this building is not that big. It's just a 5-story building. So I can choose to apply it or not to apply it. I think those days I explained about life load reduction and all that, how it is being used. and all that. Now, this building basically is for a residential building, right? Apartments and all that. It's not a hotel building. So basically, life load reduction is best to be applied for public buildings, for example, hotels and all that. And last time I explained, years ago, I explained about life load reduction and what it does. It helps, just like the name, life load reduction. It helps to reduce the life load on the structure and all that. And the whole concept is that, for example, if it's a hotel now, knowing that some hotels have up to 300 rooms, 400 rooms, and all that. Now, it is possibly for like a day, not all the rooms will be occupied and all that. And most times, it is not all the load that is used in the design that is being applied in the like on the real life during when they're using that structure and all that. So in that course, that's where life load reduction comes into play, because it's very, very certain that most of the facilities will not be used they won't be used at once and all that. So that's why life load comes into play. But I'll just ignore the life load reduction to use the ultimate, to use the highest. Then I'll not check this use spouse server. Also, I'll just select this display analytical result. I want to do this manually by just doing showing it myself. So once I've done all this now, the next thing now is to choose material for the foundation. So I'll come to foundation floor now, because we are on foundation now, foundation floors, and choose my concrete grade, which is steel grade 25. So I'll come here, make sure it's 25, and I'll choose apply to all, and just say okay. Then come to the steel grade for the foundation. Come here and choose. We are using 460 type 2, which is a rough surface reinforcement. And then I'll come here and say okay here. Now, for the links too, the same. Okay, is there links? No, there's no links on this building. So I'll just say cancel. For the foundation, there's no links. This is just a slab raft, so no beams that carry links. So I'll just ignore using the links. So I'll just come here and then say okay. Now, back to this place again, to this other place here. You can see here soil type and all that. Now, if the soil is clay, sand, or silt and all that, it's best to choose that. But now, knowing that our bearing capacity for this soil is 50 that we used yesterday, that we assumed yesterday 50. Now, at that point 50 is possibly that we will not be able to get sand. There will be a mixture of clay or silt and all that. So I can choose clay. But basically, you are meant to get all these results from your soil reports and all that. So I'll come here, I'll just choose clay, assuming that it is a clay soil or possibly silt soil. And then I'll now come down and then say, okay. So with this, and then come and do here, okay too, that's fine. So once I've done these settings now, picked all these and all that, this tab is that says slab raft, slab to stroke raft and shear element size and all that. You can leave this as default and all that. But if you can see here, minimum is 500 and maximum is 1000. I can use this to be 800 as a maximum. All what this thing means is that it's just the plate size, right? The slab raft plate element size and all that. If you make it too small, for example, now if I take here to be minimum, let me say 600, what it means is that during the slab analysis, it will take much time to run the slab analysis, because now it will divide those slabs into different element size, into plate size. And since you're using 600, it will be lower. It will take much time. It will take much design time, duration. So I can take 800 instead of taking the maximum that has 1000, I'll just put 800. So once I've done this now, then come and click on what? Floor mesh analysis here. Now on this now, you allow it for it to begin to run that. Okay. Now, if you have any issue on your modeling, this is where it will show. It will not pass this stage. This thing here will not be shown good and all that. So you just allow it for it to finish up and all that. If there's any issue on our modeling for this slab raft, you will see that it will just cancel and all that. Here will not show good. So it will display that warning for you. Most times you'll be seeing the warning like degree of freedom, DOF, error, and all that. Okay, another. So right now, I'll just this is saying that it is trying to update. It is assuming that there is a beam on the slab raft, which we don't have. So it's just saying that the foundation analysis has done what updated. So I'll just say okay, and all that. So right now you can see that our model is okay. There was no error based on our model. Let me just allow someone to come in. So there is no error based on our model and all that. So we have passed the first stage, which is the modeling. There is no error on the modeling. Now you can also see that he has not that. And even there was error on the model. By the time you say okay or cancel of that error, here will still be showing bad because the whole process was not what completed. And you can see here saying analysis was completed. So in this case now, after this, I'll then move on to the display analysis model. That's the first now. Do you hear? So I'll click on this place now. You can see our soil bearing capacity. This one should move itself. So you can see the allowable soil strength here is still 50 and all that. So let me say, even we didn't put it before, we can still come here and then put in our bearing capacity here before you can now proceed. Because now we are done with the what analysis. Now we are moving to what design now. So I'll come now and then click on what display analysis analytical model. Okay. So now it's trying to display. Let me let someone come in. Okay, it's still trying to do that. Okay, so now you can see now it has now displayed the analytical model for the FE foundation and all that. Now I'll just close this tab. Now you can see the plate size that I was talking about. You can sorry, someone should move just move yourself. So you can see how it has given this into a plate size and all that. Let me let someone to come in again. Okay. So we now have this slab now having the plate sizes and all that. So on this now, the next thing you do is to apply the contour. The contour. You can see the forces from the vertical members. You can see the forces here for each of the columns or walls and all that. Okay. So these are the axial load beginning from the last story, which is the 8th floor, down to the foundation. So these are the reactions. So on this now, the next thing to do is to now apply the contours. To now apply the contour is to click on this contour tab here. Then you choose this first contour here, which is the first contours. Now on this now, I have no need for this. So I'll just collapse this one. I'll collapse this. I'll collapse the load combination. So I have only this to like deal with. Another, let me minimize this a bit like this. Okay, that's fine. So this is now the contours, and we will use the color code now to begin to look at our tables here and all that.
That's
now,
legend.
Basically, now I want to explain this legend and also displacement here for you. Basically, when it comes to slab, and you will appreciate this more if we are dealing flat slab. Now, displacement now, the standard requires that your displacement should not be more than 10 millimeter and all that, 10 millimeter. Now, if we look at these values now, beginning from this, the maximum that we have here, you can see it here, is 0.004, so for 0.001 to 0.004. Let's now convert this to millimeter. And if the value is less than, more than 10, we have to go and work on our slab again, on our slab model. So now on this now, we have 0.004 multiplied by 1000. You can see that this gives us 4, which is less than 10 millimeter, and all that. Again, here will give us 1. This 0.001 give us 1 millimeter. So once you have a displacement less than 10 millimeter, it means that you don't have any deflection issue on that. But you like appreciate this more if you're doing a flat slab that is what suspended, because you might be seeing some of them. If you didn't model it very, very well, you can be seeing it's something millimeter, knowing that the maximum you can allow is 10 millimeter. Now you're having a 20 millimeter and all that. So you have to work on this on the slab, and how you can be able to counter that issue if you're doing a flat slab design and you're having those kind of displacement issue above 10 millimeter, is to add internal beams that will bury on the slab, knowing that flat slab you can have a depth of 300, 250, 300, 350, and all that. So you're going to have an internal beam, a concealed beam on that. You'll be putting a concealed beam on those areas and all that. That is one of the ways to like control that. So on this, and how you can get this displacement, in case you're not seeing yours, is to come to this deep Z. This deep Z is one that gives you the actual one. All that ones here, X and Y, they all give zeros and all that. So deep Z is one that gives that. So you just click on deep Z, you like see that. But in the area of this slab raft, you may not see the effect that much. As you can see, all our values is less than 10, which we just did now. Someone want to come in? Admit all. Admit. Okay, that's fine. So with this now, we then move to begin to click on each of these. These are the forces. Most times I just ignore this force because the whole forces has already been applied. I just start from what moment, but let me just apply all these forces into the model. Just click on this, not that. I'll just head on. Now, when you click, allow it to load, because allow it to load, because most times it can take time to load. So you can be seeing now, I've now entered what moment and all that. So while you're doing that, you'll be seeing you'll be checking your values here, but we will begin to check this more when we enter what area of steam and all that. So I'll just load all these moments into this. Load this, allow it to load. Allow it to load, then again this, and allow it to load. That's loaded. Then this one, and then this other one, and then area of steel based on local. Then this again, allow it to load. This again, allow it to load. This again, allow it to load. Then we now move to this area of steel. This is the actual one which we like normally use. This wooden armor. This is the one we normally use, not this one. This one gives lower values. So we'll go for this one now. Now, once I come to this place now, this is where I begin to work on with my C table. Now, before I begin to do that, I have to put this on a plan view to see it on a plan view. To do that, I'll come back to general, then come to plan here. Now, I'll see this now on a plan view, just like this. Correct. So on this now, I'll then click on my first area of steel button, design area of steel button. Now, on this now, you can see the area of steel here required and all that. Now, the first thing I do is to zoom in to see the color contours and all that. Now, I told you guys before yesterday that Slab Raft requires top reinforcement and bottom reinforcement, and then punching reinforcement and all that. Now, you can see that from the color contour that we have here and what we have here, that the general color that is shown almost everywhere here is this dark blue color and all that. Now, this dark blue color now is showing you the general reinforcement area of steel. The general, that's the general marking based on button on direction 1. That is the X direction. Now, for me to know the value now, you can see that the first value here is 0. Second value here is 216. Now, what I do is that, knowing that this is the blue one here, and we have the color contours here, the maximum here is this purple. And this purple, you hardly see it. It's very hard to see. And except you have to zoom, and it's basically most times at the corner, very tiny, or inside the column points. So if we need to check the purple color now, to see this purple color that has area of steel of 1513 millimeters square per meter. So if you need to see now, you can see where it's hiding, very tiny inside here. That's where we have this. Again, you can need to check that too. You can see that it's always hiding inside the column, because that's where the punching occurs a lot. If you also check this other column here too, you also see that too. Then there's a column here too. You can see that purple. This column doesn't have it, because maybe it's not carrying much load, so that doesn't require punching. Then this one too doesn't have it. Now, what I do now to choose my general marking, my first general button reinforcement, because currently we are at the bottom now, I'll skip this particular purple. So let me someone to come in. Okay, come in. So I'll skip this particular blue one and go higher, because if you check now, you can see the value there, area of steel. If you're going to go, is already 0 point something. If you check that very well, you can see area of 0 point something and all that. But the actual place here. So I'll skip that and move to the next higher one. So right now, I'll now pick between these two green. Let me just allow someone to come in. So now, I'll pick this green here, because after this green here, all other ones now are focused on punching. Once you pass this last green, this other orange color, that's yellow, orange color, is dealing with punching and all that. So with that now, I'll take my general marking area of steel, my general bottom bars, as this last light green here that mixed with yellow, which is in this case 800 and something. Your own case might be different based on your own design. So I'll pick this now as the general area of steel. And how do I get this? I have to navigate now back to my desktop and open my area of steel for slab. Area of steel for slab. So to come in, let me just allow it to come in. Let me just minimize this first. Or allow kilobyte was okay. Yeah. Okay, that's fine. So right now, back to my image here. Sorry, not this one. Image here. Okay, so right now, let me go back to the area of steel and look at what we have. Now we have this now. We have 864.6, approximately 865 millimeter square per meter for the bottom direction 1. So I'll come now back to my area of and all that, and look at between diameter 12 and 16. Basically, for slab rafts, it is best you use diameter 16, even for flat slab. So I'll look at these two first. Where I can get that 865 area of steel. So I'll come now, and then at 16, 865. It falls. Yes, basically it falls under here. That's spacing of 200 M16. Can I see that diameter 16 at 225 spacing? I know that. Why 12 or 12 diameter is not advisable to be used even for flat slab and for mat foundation. I know that, except maybe you're doing for a very small building. Let me say a building of just 1 bedroom, and one bedroom and all that has very, very lightweight. Then you can just use that, but it's not advisable. The best is to use the minimum is to use diameter 16. So under diameter 16 now, it falls under 225 spacing. But for me, based on my own, what I do is that I basically work with 200. I take 200 as my maximum area, as my maximum spacing of bar. So if it falls anything more than 200, I'll just drive myself back to 200. I'll use 200 spacing. So if this was to be my personal design and for a client, I'm looking for a client, I'll use 200, even if it's okay at this place. Now, there's a reason for that actually. The reason of me, because right now it doesn't fall here. We have 865 as our what area of steel. So 250, it then doesn't fall at 250. So it falls at what? At 225 spacing. All right. Now, the reason of me driving myself backward, at least one spacing backward from the main original, what the actual design gave me, is because so many things happened at site during the construction. All right. Now, knowing that my area of steel is giving me 865, all right, for the bottom reinforcement, and the spacing is to be 225. At site, those people that are laying the matting, those laborers and all that, laying the matting, they might end up giving you a spacing of 230 or 235, most times 240, and it's possible they can even give you 250. And knowing that, yes, you are meant to check their spacing, but you see that you won't be able to check every spacing because it will be too much for you to check. You understand? So just to avoid any of those issues for what you designed for, they're not applying it at site. I like to drive myself back to one spacing backward. So in this case, I'll use T16 at 200 spacing for my bottom reinforcement, so that if anything happens at site, they will end up giving me, let me say, if they didn't follow it, because most times they'll be rushing and they might end up marking 215 or 200 and something. So they might end up falling around 225. You understand? Which is still within my actual area of steel that I use for my design and all that. I don't know if you get the whole scope of what I'm saying. So right now, in this case, my bottom reinforcement under direction 1 is T16 at 200 spacing. So what I'll just do right now is to, let me minimize this. Let me just open up a text note. Text, okay, that text note, that's fine. I'll open it up right now, and I'll just type, okay, so I'll type now, bottom bar, bottom. I don't know if you can see my screen. This is very tiny. I don't know how to zoom up this. Okay, I think, yeah, it can be zoomed. So just that.
Yes, we can zoom it from here. We can zoom it from here.
But, yeah, bottom. I'll just say this C16 at 200 spacing. That's my first one. Now note that what you have just done is direction 1 of the bottom bar. Now we have no direction 1, which is the one going horizontally on S axis. And that, let's now look at direction 2 of T bottom bar 2. Direction 2. What's our area of steel here? Let's see. I'll click on direction 2 now. Now, I'll still go again now. You can see. Now we are having this green one now falling at 1075. All right, as area of steel. If I still look at this and all that. So right now, you can see bottom bar. Now we are taking green. Don't forget, we are taking green as our general marking. That's what we are doing now first. General marking for the bottom. We are taking this one and not the blue. Even if what we are seeing here is the blue contours and all that, which would have fall around 200 and something. But I don't normally take that. I go to take the actual area of steel before the orange. Because from this orange now to this purple one is actually for punching under the column. So with this now, this my green now falls on this 1075. So I have to go to my steel table again, steel table, and look at under the 16 where falls 1075. Now 1075 now falls here, falls under this. You can see it doesn't fall under 200. This is 1010. So it falls under this place, 150. All right, 150. And our area of steel is giving us 1075. So between 1075 and 150, there's a gap difference of area of steel of 75 and all that. So if I'm picking my spacing now, which falls here at 175, what if there is a mistake at site during their lane of their rebar and they make a mistake and fall it around 180? 180 will be giving me around 100 or 10 something and all that. So basically, you can choose to use 175. This is now 175, or you go safe, or you go safer. T16 at 150. All that. Now, your question now, or what you are thinking might be, are we not increasing cost for the clients by going lesser spacing instead of 175 that we have on our design? We now go 150 and all that. Now, how this now comes into play is that one, when you're doing your design, you like look at what will happen in reality at site. Now, most times we know that in Africa, basically where it happens, you that did the design, they might end up not calling you for the construction. They might go and use either the client might call someone else that is close to him or her and all that. And that engineer actually did not know what you looked out for when you are making these options, doing your design. You just look at your drawing and all that. And if there's any mistake at site, let me say during the spacing of the enforcement, they did, instead of 175, they are doing 225. You might just say it's nice, ignore it, understand, and all that, which might give issues. But if you're the one at site, you already know what made you to go lower in spacing. So at that point, since you're the one at site and you're sure you are going to check everything, even if the final drawing that you gave out is 150, all right, you might now, since you're the one now at site, the engineer at site, you say, okay, actually, based on design, this thing gave me 175. So you can give the right directive to the people laying the reinforcement that please make sure you use 175. Don't exceed 175. And then if you have the strength, which you're meant to have, you have to make sure you check each of the spacings and all that. So knowing that even you checking might even have, you might get tired checking. So it's possible, it is best you go lower and say 150. Like if those people lay the reinforcement make mistake, they might end up giving you 175, which is still within the area of steel. Yeah, I don't know if you've gotten the scope. So in this case now, I'll use 150 based on my principle. I'll use 150, T16 at 150, all right? T16 at 150 spacing. Even if my design falls T16 at 175, all right? I'll use this one here at 150. So, and now it is still a bottom bar. Now, I'll now come back here right now, open back my, where I'm putting this, copy this entirely, copy, come back, sit down and paste it and change this around to 150. Sorry, 150. Now you can see that now these two, they are bottom bars, and basically based on the best practice, it's not good to have different spacings on a particular reinforcement. For example, we are at the bottom now, and now we are having 200 spacing on X direction and 150 at Y direction. This will even give more confusion to those iron benders laying the reinforcement aside. So it is best you give them one spacing so that their brain will be able to capture that the spacing for the bottom reinforcement is 150 or 200. So in this case now, we will take the lesser one. So with that, this 150 now overrules this one. So I will have to remove this. And now my bottom reinforcement spacing now becomes 150 on both directions. Okay. I don't know if that's taken. Okay, so back to this place now. Sorry, can you still hear me? Let me see that.
Loud and clear.
Okay, that's fine. So right now we have now gotten our bottom bar. Now we now move to the top bar. Top bar on the slab raft is basically not much. It doesn't require much. Where you have to require much is when you're doing slab raft. So flat slab. Flat slab, top bar controls more than the bottom bar. But in slab raft, the bottom bar controls more than the top bar. But in general, we tend to make it the same thing. What we have on the bottom also make it at the top. So let me now go for the top. Now let's now go for the top. Top direction 1. Top direction 1. So you can see the top direction 1 now. For the top bar, knowing that we are still taking our general bar. Now, our general bar for this lighter green here and all that. Now, you can see what's happening here. Knowing that the top area does not have anything like punching issue. It is the bottom. It is the bottom that has the punching issue because of the column contact with the slab at the bottom. So the top does not have punching issue or anything. So you can see at the top now, at the bottom, we relied and took our general rebar at this contour, which is the last lighter green or greenish yellow. Now we can still extend and even take up to red for this top, which is still be lesser than what was at the bottom. So right now you can see your area of steel and all that. In general, top bar for slab raft is always less than the bottom bar. So you can see that. So at this place, even if we are to choose 870, 876 and all that, it can still fall within delta 12. So if we say now this purple here, you can see that the purple is around this place here, around this place. The purple is basically around the edges. So there's no purple again except that area, this other place. Now, how you can be able to counter this purple issue? Don't forget, let me go back to our this thing now, our 3D bar and 3D interface. Let me show you why this is happening. This purple is showing here around the edges. Now, don't forget, yesterday I told you that basically on our modeling we are meant to have a small, that this slab is meant to extend outside this perimeter column, at least 300 minimum and all that. You understand? So, but I told that you can still do that. If you don't have time to like do that, you can skip it and do it and make sure you apply it during your detailing. Just extend the slab by 300 minimum. You can go 500 or 300, but 300 is the minimum. So the reason why we are having that place purple is because of the pressure. Since there is no slab around after the column, around the perimeter here and all that. So the load on the column is hitting directly on this slab a lot. But had it been we have this slab extended a bit at least 300, that load would have had a counterbalance, like to be able to spread very well and all that. So with this now, with that notion, back to this place now, that's why you are having let me go back to the place. You are having this purple. Let me just go back to the place. Okay, yeah. At the edges, can you see that? We don't have it anywhere inside and all that. You can see that. It's only at the edges. And that's just the few edges. You can see. So it's just to help to spread. And even we had that slab extended at least 300 or 500. But 300 is minimum. That's what I use, 300. You'd have seen that this purple here wouldn't have had that purple and all that. So even if we have to take purple here, and purple, which is 1022 as our final area of steel, general area of steel, it will still fall within diameter 16. Sorry, 16, let me see that. 1022, so we can take it to 1025, which is the round figure, 1025. So diameter 16 now, 1025, it still falls 1025, it still falls within 150 and 175 spacing and all that. Understand? Yeah, but most times, most people, if they want to save costs, since the bottom bar gave us diameter 16 at 150 and all that, why the top now? The top, if you to follow that guidelines of this purple here and all that, or this orange, which is the maximum, you can see that you can get 730, 876, and that can fall on the 12. Let me sorry on this one. In the 12, so you can get 8 or let me see 830. I think 830. Okay, 876. Let's say 880 at maximum. 880. Come here. And the 12 as 880. That falls at, you can see, it falls at 125 spacing, which is very, very small. Very, very small. That's why I say M16, right? Diameter 16 is the actual bar you're meant to use for your slab raft. Because if you're using 12, you'll be having lesser spacing and all that. So even that A16 falls at this spacing, falls at 905, 125 spacing. It's very small. So we will take it to be, we can now take it to be top bar now. That's 1025, which is the maximum purple that we have here, which is maximum, falls at 175 spacing. 175 spacing at T16. 175 spacing at T16. So we can say, okay, bottom bar 150 spacing, T16, top bar 175 spacing. At that is if you want to save cost. But most times, most people just use the same thing at once at the top. So right now, we have to take T16 at 175. This is where it falls because we have 1025. It doesn't fall here, so it falls at 175 spacing. So we'll come now, open this, copy this, paste this, and change this to top 175. So these are our first top. Let's now confirm the other direction. Then we're gonna pick one of them. So come now again and click here. We'll click here. So on this now, you can see that this one now has 907. So invariably, this other direction rules, right? Rules like it like take the highest. So because we are taking the highest among the two direction. So this other one now is a less. We have 917, 920 approximately 920 at the round figure. So this other one now, which is the direction one, we will have 1022 rules, and that's how we like got our value for T16 at 175. So at this point now, we can say that the general slab reinforcement for this mat foundation is bottom reinforcement T16 at 150, for the top T16 at 175. Okay, you can choose to make it the same if you want, but this is the actual one that came from the design and all that. So using this, you have no issue on that based on general matting. Let's now go for the punching and all that. So back to this place now, to this other place. We'll go back to the bottom bar again. Now, bottom bar now, knowing that punching occurs more at the bottom. Now, bottom bars now for the bottom direction one and all that. Now, bottom direction one now and all that. Now, that one we had was the general matting. Now, if you look at this, you can see this point you are seeing, this sky blue or something, is where we have the column points and all that. We can also get that by going to solid model here, solid model, which takes some few time to load. It can take like some minutes, no, some seconds, actually seconds to load. Then go back to go out from the plan view. I'm to go from the plan view. Sorry, here. Okay, orthogonal is diagonal. I want to make it to rotate back. Okay, let me just rotate this, correct. So if I go to solid model now and allow it to load, okay, then so you can see our columns now and all that. So punching basically occurs under each of these columns and all that. Under each of the columns, that we have our punching occurring and all that. And most of the times, it's not all the columns that will need punching reinforcement. Because punching reinforcement is based on the load each of the columns they're like carrying. As you can see, each of the column load now, they are different. This one now is 437. This one here is 230 something. So based on the, now that's the maximum load here. Maximum load here is saying 809, which is the one that are what blue. So you can see the ones that are blue. You can see them. All the blue ones has a value ranging from 809 and 809, 807, and all that. So you can see these two blue, which is still around this place, blue 7 something. Okay, so right now it is the one that have most heaviest loads that will carry those punching reinforcement and all that. So I'll go back now to my going back now to contours here. Then apply contour again. Now we are on the bottom reinforcement here. Okay, it's coming up. It's coming up. Okay, that's fine. So I close this up. Okay, so on this now, on knowing that, I'll still go back to, okay, I can still be here, but basically I like to be on the plan view to see everything very well. Let me go back to here, plan view. Plan view. Plan view. Okay, that's fine. So with this now, now this, I say that this orange and to purple they are for punching and all that. So now you begin to look at the ones that has that. Make sure you zoom in very well. Now you can see that this column does not have anything yellow and all that. And note that when we are doing our general marking for the bottom, we use this last light green, this green that has light yellow with it. So you can see that on this column, the only contour here is the one that is this light green yellow, which you have already factored in. That's what we used for our general marking. That means that the general marking can be able to carry the load from this column and all that. So we will leave this column now from punching because it doesn't have any punching issue. We then move to, although I'll still show you how to check for the punching. There's a tab for the punching to check for the punching again. This other one now has orange, red, and purple. So this one now we have to what governs now is the purple value. That's what we will use. So this column here has that. This column here has that. Now internally, let's internally. This is a light green or yellowish green and all that. Let's go. This is T8, not that. So right now, if we now go and check for this reinforcement here that has 1513, so can take approximately 1520. That falls between this. It falls within this. 1610. That value falls in. But now, based on that space is very small. I'll leave from 16 diameter. I'll move to 20 diameter. So on 20 now, it falls under where 1520. That's 1513, but let's say 1520 at maximum. That's like a round figure. So I'll work on that. 1520, that falls on 200. So right now, we are going to take all the major columns to be 200, T20 at 200. T20 at 200 as what additional reinforcement to take care of punching. So right now, I'll go back to this place now, to this place here, additional reinforcement, additional rebars, T20, T20 at 100. Okay, that's fine. So let me just allow someone to come in. Okay, Francis. Okay, that's fine. So right now we are gotten what additional reinforcement for the major columns to be what T20 at 200. Now, how do we now place this bar at the bottom? Let me just show you. I think most of you that has the Stonebridge template must have seen that reinforcement on the Slab Raft. Although this one, I would have showed you this for like tomorrow. Let me just open that. Do I have that? Let me see. Someone come in. Okay, Malik. I go to this. I'll just work on this. Okay, this. Sorry. Let me see.
Well done.
Yeah, safe for that, yeah. Okay. Okay, so just minimize this again. So on opening this now, let me just go to Slab Raft. This, yeah. Okay, it's coming up. So you will see how to place that additional reinforcement under each of the columns for the major ones. Is it open? It's the opening. Okay. Okay. Okay, that's fine. Let me open that up. So you can see now, this is a slab raft that I did that was 2019. In 2019, this is a slab raft design which I did. That's for an event center. So you can see right now, you can see that each of the major columns, not all the columns are having that. You can see some columns do not require that because that bar, the original bar is already able to carry the load from that column. But some column requires that, as you can see, and they have different sizes, all right, perimeter based on their punching. So you can see how that is being placed. Let me see. Yeah, you can see that. I want to turn this. Let me see. Space. I want to see how it's placed horizontally. Let me just see. Now this one. If I turn this now, let me just turn this. Rotate this. Rotate. Okay. All right. So you can see how this is placed and all that. I'm trying to download the site construction of this building, because I think I had some images of the foundation at site. So this is the general reinforcement for the mats that we did. Let me say in this case now, our general reinforcement for the bottom gave us T16 at 150. So this bar that you're seeing here at the bottom, general bar you are seeing here at the bottom, let's assume is the T16 in this case. Then for the top now you can see I used the same bar for the bottom and for the top. As I was saying, most people choose to use the same instead of having different spacing for the top and for the bottom. But if you still want to save cost, knowing that the top does not require much, it's always less than the bottom, you can choose to reduce your top spacing and all that. Then, for example, we all know what is this. This is a shear bar, which is used to support this other top bar. So this is now the additional, exactly, to separate them and the support. Else it will fall down from the top zone. So you can see now this is now the additional reinforcement. It's basically placed like a pad footing under each of the column on top of the bottom bars for each of the major columns. Let me just try to take the let me see. I think I have this site image. Let me see if I'm able to share that with you. Let me just see that. So why I'm checking this? Any question? Let me just know. Why I'm just trying to get a clearer understanding for you. Let me see. Do I have this on this space? Do I have this? Okay, I think it's on this one. So any question? Why I'm doing this? Sorry. That should be somewhere. Okay, yeah. Let me share it to my desktop now. I've seen the image for this slab raft, and like the site image of the slab raft. Let me just share it. Open my Bluetooth. Let me just share that for you to see. Bluetooth, receive. Come on. I'm coming. Let me just share that. Okay, let me see that. This. Share again. What's this device name? Let me see. Let's do this. Okay, yeah, it's coming. That's fine. So let me share that. Okay, it's coming up. It's like 5 images. In 5, 1, 2, 3, 4. Okay, 7 images. Yeah, it's coming up. Still coming up. Okay, yeah, I think it's done. So it is saved in saved in this document. Just say, let me just save it somewhere. Create a folder, make a folder, images. Okay, inside there. Okay, that's fine. So I'll minimize this now, and then minimize this, The folder image is correct. This is it. So I'll open this up. Okay, so right now, this building that drawing you just saw now. This is the construction of that building. That was 2019. 2019, yeah, and this was me 2019. Now you can see the reinforcement, right? Maybe I think it might be blurry actually because of the phone I used to capture it those days. But let me still be going further. I think I might have a clear one. Yeah, correct. I think this might be clear a bit. Now you can see. Can you see my screen? I don't know.
Yes, sir.
Okay, that's fine. So this is a mat foundation or slab raft foundation construction. You know that. So you can see if you check around this column area, it's like it's having more like a more reinforcement than on this other face. You can see that. You can see water under this place. They're shining something like white. But on this column area, you can't see that because of the much bars that is under this column. Let me still go for that. You can see I think this might be clearer a bit. Yeah, I don't have videos for this, and my system crashed, so I don't have all the videos again. Just this image. Okay, I think this is still. Yeah, you can see. So this is the slab. This is a slab raft, and this block wall here, they are the perimeter block wall that we use as like a profile instead of using wood, because if you use wood, by the time you're done casting, most times you'll be able to remove that wood again. So instead, we just use block work to do the profile and all that. The profile. So this is the slab raft. Then again, let me do it again. I'm trying to see if I can be able to see the punching reinforcement. But you may not be able to see because of the phone I used. It's not that clear, and it is an old image, very old image. Let me see go for that again. It's not showing clearly. Okay, this is during the casting. You can see this is the casting process. This is when they are casting the foundation slab and all that. Then okay, this is the casting. Yeah, I think I don't have much. So, but this is basically how it's been done. You can see the shear bar here. There's a bar here. There's a bar here, something like this. You can see the shear bar around here. It might not be clear that's damn. Yeah, but this is basically how mass foundation is. It has bottom bar and top bar, and the depth of this foundation is I think 750. Yeah, 750, because this is the drawing. This is actually this one that I just saw now. This is the drawing. So I think it's 750. Okay, no, 850. Yeah, 850. It's 850. The slab thickness and 150 blinding. God of that place, while you're digging, there is this thing coming in. Sorry, not blinding. 150 sand filling, sharp sand filling, and 75 blinding. So altogether, we have 1075 millimeter as the total depth of the foundation. Yeah. So, and also there's also felt. This is a felt material that is done after the blinding, just to prevent direct contact with the reinforcement water and all that. So that thing that I just saw image is basically what this is the drawing and all that. So these are the punching perimeter. You can see it here. This area here, they say punching perimeter for supporting reinforcement and all that. Most people can call it additional bar, but they are basically found under a column. All slab rafts must have that for the major columns and all that. And yeah, must have that. So this, yeah, we use 850 for that, 850 for that. So you can see how they are being placed. So this one now, these ones that are yellow are the general bar. This is 16 at 175, both top and bottom. Why for the additional are the red ones? These are the red ones. You can see 25 diameter. That because of the weight that was coming on this column. Another 25 diameter at 175. Although there are some that also require 60. You can see that this one requires additional 16 again. These ones are very small, but they are very small. And some are 20. Yeah, I can see this one are 20. So it's basically based on the load. This building has a very massive load and all that. But this one that we are doing now, you can see that most of them here does not require that. Else, you have seen that most of the columns at the center will be having that. And basically, I won't blame this because the load, this building is for what apartment is. It has a load of 1.5 QK. That's the life load, and 1.75 GK. That's the dead load and all that. So why on this other side, this building has a life load of 5.0, and a dead load of 2.5 and all that. Then other load, and there's also a steel. It also has a steel roof. So the load on the columns we are much. That's why you can see that it has very large diameters, which is here. You can see that having 25 diameters for the additional reinforcement and all that. Okay, that's fine. So this is basically, hello? Yeah, I hear you. Sorry, are you asking a question? I don't know. Sorry.
Yeah,
okay, yeah, okay, question. The question.
It's concerning the punching reinforcement. Is there a specific dimension for it?
Say what? Sorry, say what?
The punching reinforcement, like, is there a dimension for it?
Yes.
Okay,
Yeah.
What you do, for example, now, yeah, Yeah. Now we have gotten the value, the value as T20 at 200. Right. Now, how do you know? Let me show you now. How do you know the punching perimeter area? Like, let me show you now. How do you know this distance? Right. That's what you're asking. From, let me say, from here to here. Now, the formula is 0.25 times the span. For example, now, if I come back to this layout now for this slab raft, consider grid line. There's a from this place to this place, we have this value, right? We have 11 point something. But basically you need to work with span. So if I go back to where I have the beams and all that, yeah, correct. So this is where we can see the panels and all that. So this is now a plan from here to here. This is 5 point something, and from here to this other column panel here, this is this. So we have to do 0.25 times this value will like give you the distance of the pointing perimeter from this just offset. Let me assume that 0.25 times this is giving me, let me say 1.500 to this. So I'll have this here. Let me change this to orange, to red. All right. Again, this is that one, 0.25 times this value. Let me assume that it gives me 1.7. That's 1,700. So I'll set again 1,700. So basically, that's the formula, 0.25. So I'll come again here. This here. So with this now, I've gotten for this direction for this length. I will do something again from here to here, get the length of this span again. So that's how you get. Let me just move this so that I'm not confused. That's how you get the punching perimeter, right? Now, if I go out from here now,
All right, thank
go
you.
back. Okay, that's fine. Go back to my plan view here. Story 0 and others. Story 0. Now, basically, if this was to be like a flat slab on this place, okay, I think we can see it here. You can see here I said calculate column punching check, right? Column punching check. So if I click on this now, although I normally use this when I'm doing a flat slab. Someone wants to join. Someone wants to join. Okay, that's fine. Now you can see this is for punching check, column or wall punching check. Now, before you must begin this, now that we have gotten our values for bottom bar, top bar value, facing, bottom bar facing, and everything, additional punching reinforcement now is T20 at 200. At what 200. So you can see here is giving you T12 at 250. We have to modify this first before we can begin anything. So I have to come here, close this first, come to our settings here, settings under foundation. You see that foundation, then minimum T20 because that's what we got in here. 20. Then what again here? That's that. Or for that, say okay here. Sorry. Come back to this begin. Settings under slab. Under slab now. Rebars. Under rebar slab. I'll come here and change the maximum spacing now to be what I have on this place. 200. So I'll minimize this, 200. Then minimum rebar. I've already gotten that to be 20. So I'll put here. Then on this minimum, I can just put here one, just leave that as it is, the first 100. But I only use 125. 125 as my minimum. So I once put this now, I then say okay here, okay it. Then make I save first before I continue. Save it. I will now come to once it's done. Sorry, someone should move. I'll then come to once it's done saving. I'll then come to column punching check. It is saving. Because if you don't do that, it will use that 12 at 250, which is there for like a default to like use for check for that. So the join. Coming. So this. Okay, so with this now, I'll then come and click on this column punching check here. I like to like open up. Now, let me see this. Let me see this. This now. This is most times stressful. You will have to change it again. Changing this now. So I come and changing again to this 20 minimum of this 200. So this is actually the one we are meant to use. There's no way you can be able to modify it at once. That thing I just did not work. Most times I do change it here manually. Let me just put 20 here. You have to, so it takes time a lot. It takes time for you to do 20 changes. I'll just change few of them so that you just get the whole scope. Let me just change few 20. Let me see. Someone send me a message. Let me just see. So change this to 200 to 200. 200. Okay, 200. Then these two. That's fine. So with this now. But you meant to change all of them as it is. Then now come and do what? Click on hash floor. Hash it. You have to hash the floor area. Right now we have hashed the whole floor area for us to check the punching perimeter and all that. So someone to come in. Come here. Admit. Okay, so with this now, I'll then come and do what here? Calculate. But not that you're meant to change all these values here to what you have. T20 at 200 based on your own design, right? Then allow it to finish up.
So what about the include the column walls and beam edge?
You can just include it actually, but you know that since you have not modeled this other side, understand? This thing there's no slab extending outside the column.
Okay. Yes, we did not do it.
Yeah, and all that. So now once it is done checking, it will give you the report immediately. Now, if anyone is failing, you'll be seeing it showing not adequate. Let me just zoom in. Not adequate, all right? So I'll now begin to go. Just check a bit. You can see them all adequate. Now, most times, this is very, very tricky.
Not required.
You might see, yeah, they'll say punching equipment not required, all right? But for the major columns, you just provide. Understand? You just provide them. Now, you just be going. If anyone is not adequate, they will like show not adequate. Although you are going to enjoy this more if you're doing a flat slab because you'll be seeing most of them failing on a point on a punching. So let me just start the going. There, some adequate. So if anyone is failing, they will like show red. and then you'll be seeing everything here will be showing red and all that. So let me just go at the page. Let me just go down. So you just have to check all the reports and all that. If anyone is failing, you like see the column that is having the issue. For example, if this one was failing now, I'll just go and trace column 1C31 and go and check and all that. So just go. And basically, when you're having punching failure and all that, if they are saying adequate and all that, if you don't want to control it more using the reinforcement, you just have to increase the depth. For example, now we use 750 as our depth of slab raft, understand? So you can now increase to 800, 850 and all that, or 775. You'll be trying different depths. So let me just go down, adequate, just go down. Adequate. Now, if it is a very long report, for you to just know the one that is failing, actually, come to heading here. Here that says heading. When you click on heading here, if anyone was failing here, you will see it. You will see that there will be a failure sign here, like exclamation mark. We just show at the top here. It will show with this column punching check. It will not show that those marks will show, showing you that one is failing or two is failing or more is failing. You just scroll down to it, and then you just see the one that is failing. It will just show red. It will also show red around here. You can then begin to now go and trace it. You can see anyone I click will just show me the page and all that. You can see that. So in this case, no one is having any punching issue and all that. But we just provide what? We just provide it for more safety. Understand? So with this now, you can see that they are all adequate. I will then come and close. You can choose to create a PDF for it. I won't do that because most times it takes time to like create the PDF. I'll just ignore that. Close this, and I'll now say close. Now you can see what's happening here because all of them was adequate. All right. What it means is that this our general bar, which is T16 at 150, was okay to like control all those stuff, to like control punching. That's why I see that they are all clashing with each other. Means that they don't require punching reinforcement, but we are still going to provide for the ones that we saw. So like these ones here that are showing purple issue, and the ones that has much column load will not provide for them. For example, if I go back to this other place now, we are able to like detect the one that has that has heavier loads on this our solid model here. Solid model. Then make sure you are on the 3D interface. So let me just go and turn off this plan view. Make sure you're off the plan view. Come in. No, yeah, must be off. Then yeah, correct. Yeah, that's funny. Then come back to solid model. Allow it to load. When it loads, it will change the correct. Then I choose to rotate like this. Use your mouse to rotate. Now, if you look at this, these are showing you all the column loads and all that. Now you can see the maximum here, 807 and 7 this. So if you look at this now, you can also see the colors here. So the ones that has the major column loads and all that, we can choose to provide punching for those ones. But we already know that it doesn't require punching enforcement based on our punching how we just did now. but we'll choose to provide for these other major ones that are having blue and all that. And if you look at that contour, these ones that are having blue, has that purple color, has that purple contour color and all that. So you can choose to provide for those ones. Why these ones that are showing green, yellow and all that, you can choose to ignore them. They have lesser column loads, which that T16 at 150 for the bottom enforcer can be able to carry it. Now, if anyone is going to require punching, you will like see it based on the column load and based on that contour too. You also see it. And from the punching calculation that we just did, in here, back to this place. Still coming up. Yeah, you will also see it here now. If you know what was failing on the report, why you come here to, you see that this thing, that one that is failing will not be showing green. It will be showing red and all that. That means that it is failing on that means that that you need a punching enforcement much on that place and all that. So either if there are many, you either increase your depth of slab, increase a bit, or you provide more punching reinforcements, 55 diameter, and most times 30 diameter, and all that. Okay, that's fine. Now once you change, this thing you're seeing now will not be forever. Once you change to, let me say, story 1 now, and come back to story 2, sorry, to like story 0, most times all this punching stuff you're seeing will just vanish. It will just go off. So if I go to story 0 now, you can see you won't see it again. So whatever thing you are doing, like to study within that soil, that punching this thing, make sure as soon as you're done with the punching check and all that, point out the column with those failures and all that. Because once you change your story in your plan and come back to your story 0, you won't see those punching area again and all that.
Or you screenshot.
Yeah, correct. You can also do a screenshot by using window shift X, or use your phone to snap it just to get that. Else you have to do it again and all that. Okay, that's fine. So tomorrow I'll show you how to get the report. I believe from the drawing which I just showed you now is already clear about how to perform the structural detailing for that. It's very clear. But tomorrow I'll still show you how to do that. So tomorrow we are going to end on this slab raft and all that for the slab raft tomorrow. You are going to appreciate it more had it been this video was having much load. For example, if your life load was around 4 point something, for example, shopping mall that has 4.0 or church building that has 5.0 and all that, you will be seeing how you'll be having much punching and all that. But this is just the whole process of how to do a slab raft and all that. Okay, let me get your question. If there's any question so far, I think yesterday we like took much time because of the modeling. It took much time. Okay, let me get your question so far. Most countries now, they are already at 11 p.m. or not 10:30 p.m. For example, like the people that are in Zambia, this is almost Uganda, almost 10:50 or 10:40. So let me get a question. If no question, I think we are almost done. We can call it a day for today. Yeah, then tomorrow we will do now tomorrow, knowing what we have so far. So let me just see that. Tomorrow we have slab
detailing.
Yeah. So what will happen tomorrow, because I'm just assuming tomorrow might be too, and that flat slab might be too short because we have already done much. So we might not be able to finish that within 2 hours. So we might move to also touch a bit of earthquake So if maybe within 1 hour we are able to finish this slab raft and all that, we then move to earthquake, because this earthquake alone, even this day 4 alone cannot be able to finish that. So because only this one alone, these design principles can take almost 3 hours. So what we'll do tomorrow,
2 days, man. Even 2 days.
yeah, almost 2 days. No, I'm just saying almost 2 days, yeah. Because the whole concept of earthquake lies in this design principle. Yeah. Once you know the whole principles and all that, then you're like good to go. The rest is just to apply the principle into. So what we'll do tomorrow, this day 3, this slab raft detailing might be, because we have already done punching, design, everything. So just to show you the detailing, which I'll just show you few. I won't do all the full detailing. I'll show. I can just do one part, and that can be just 1 hour. So the minimum 1 hour we use it to do the earthquake design principle. Then continue again for day 4, partly day 4 in there, not that. Okay, that's fine. So I don't know if no question for today. I think we can call it today, because I just came back from work and then just started this. Okay, that's
Yes.
fine. So any question, let me know. Any
Just
question?
to add to what you have said.
Okay, that's fine. I've not seen
Yes.
Engineer Michael from Ghana yesterday. I will try to chat him up. Engineer Michael, I've not seen you yesterday, today, and that. And he's very active. So okay, yeah, you can add in your first. You can just add. Let me know.
What about Ishaku? Is he here? Shehu rather. Shehu.
Yeah. Shehu is here. He was the second person that joined the training today.
Okay,
He's here.
I've seen. He has given a sign. Yes. All right. I think for the sake of those that were not around yesterday, you also mentioned it that when it comes to mat raft, which some people call slab raft, we have 2 ways. We have 2 ways into the design, which we can use the method of flat slab method, or we use a manual method. And
Okay,
part of the flat slab method is what you have also checked by going to click on that punching check, which is still part of the principle of a flat slab method. So that's just what I want to add for the sake of those who are not around yesterday. That we have 2 ways of designing mat raft.
Okay, yeah, that's true. So yesterday I was saying that there are 2 ways of designing slab raft. Either you use slab raft flat slab method, or you use this manual method, which I just showed now. This is the manual method, and which for me, this is the one I like trust more. Although that one is still okay, but I don't use it. But this one, this is the one I've been using for all the buildings I've done so far and all that. And I trust this one more and all that, because this one works with your experience and all that. You're the one to check and all that. Why did that one? You literally depend on what the software is given and all that. Even I still use this same principle if I'm doing flat slab. Even if I still use the that flat slab FE strip, I still make sure I check this and use this principle too. Exactly, cross check, because most times software can be giving you wrong thing, because what you give the software is what the software will give you back. So, but this one is what I trust more, by checking, using the area of steel and all that to like check what is what I'm to get. Understand? So this is the method I use more. That is why I say let me teach this and all that. But for the other method, like as you can see, we don't have much course video on slab raft and all that. But after this our 1 week anniversary, we will do a comprehensive video for slab raft for the 2 method and all that, so that anyone you can be able to choose anyone which is easier for you and all that. Okay, that's fine. 3 minutes to 8 p.m. So I think if no question, we can call it a day and all that. It's nice seeing everyone here. This is not the place. Let me see. Okay, yeah, it's nice seeing everyone. Yeah, I think we have more people than yesterday. Today we have
Very
around
well.
25 persons here. So please also recommend your friends and colleagues for tomorrow. Tomorrow we will touch on earthquake, even if it's for day 4. But we'll touch, because tomorrow cannot be just be only for slab raft dealing. It will be too small. So Dylan, okay, Mohammed, you have a question. You're raising your hand. Oluwatobi too, you're raising your hand too. I don't know. So you can ask a question while we have 3 minutes to go. So if, okay, Oluwatobi, your question. Yeah, your question, yeah, let me hear you. Your question, let me hear you too, yeah. You can,
No, there's no question. There's no
okay,
question.
because you're,
Thank you.
okay, yeah, okay, yeah, thank you. That's nice. That's okay. Okay, so if no question, we can call it a day. Tomorrow, still 6 p.m. We will first of all deal with slab raft detailing, which will not take much time. It won't take much, let me say, highest in 30 minutes. They will move to earthquake and design principles. Yeah, that's nice. Okay, so I think I'll see you guys tomorrow again. Thank you so much for everyone being here. Yeah, bye for now. Bye then. Yeah, bye.
Thank
All
you.
right, bye,
Bye.
sir. And bye,
Yeah.
everyone.
Okay, that's nice and that's nice. Let me stop the recording before I close. Recording. Sorry.
So I hope you are saving the
Yes. You need to send.
record.
Yeah. 7 minutes. Yeah. So stop.